Welcome to this K2view test data management demo, showcasing our seamless integration with Couchbase. In this short walkthrough, we'll cover everything from initial setup to advanced data provisioning and synthetic data generation. Let's begin by integrating K2view with Couchbase. First, we install the Couchbase connector directly from the K2 exchange. This pre-built connector allows K2view to interact natively with Couchbase's distributed architecture. We now configure a new Couchbase interface. Here we provide the necessary cluster connection details, authentication, and bucket mappings. With the interface in place, we configure and run the K2 catalog to inspect the Couchbase schema. The catalog reads from your bucket structure, identifying documents, indexes, and key patterns for optimal data modeling. In addition to schema discovery, the K2 catalog also classifies and tags personally identifiable information, or PII. It automatically identifies sensitive fields like names, emails, or national IDs and assigns metadata tags based on data type, format, and content patterns. This step plays a central role in automating data security and governance. By tagging sensitive data upfront, K2view can dynamically apply masking policies when data is provisioned from production to UAT, ensuring compliance with internal policies and external regulations like GDPR and HIPAA. These same definitions are reused during synthetic data generation. They help determine which fields require fake yet realistic values, preserving data models and referential integrity while eliminating exposure of real personally identifiable information. Now, we build a new data product, this one centered around a hotel entity. K2view models data at the logical business object level, in this case, a hotel. We extract a complete 360-degree view of each hotel, including general information, location, rooms, bookings, reviews, and public likes. All related objects are joined in real time, forming a unified and consistent view of the hotel entity. One of the unique things K2view does is transform the native Couchbase document into an entity relationship, ERD-style, tabular structure. Instead of treating the document as a single blob, K2view breaks it down into its component sub-objects, such as hotel detail, reviews, location, and public likes. This approach gives us fine-grained control over each part of the document. We can independently mask, clone, or generate synthetic data at the sub-object level, while maintaining referential integrity and business logic across the entire hotel data product. With the data product in place, let's move to data provisioning. In this example, we provision test data from a production Couchbase cluster to a UAT environment, while enforcing privacy policies via masking. Here's an example of masking rules applied to the hotel data product. Fields like hotel name, location, user reviews, and public engagement metrics, such as likes or ratings, are all masked according to policy. K2view supports deterministic, format-preserving masking that is both unique and consistent. This ensures that the masked data remains realistic, testable, and referentially intact, so the same original value is always masked in the same way across all related documents. One of the powerful capabilities of K2view's TDM is the ability to back up masked datasets and restore them into isolated test environments. This enables full reproducibility and consistency across test cycles, making it easy to recreate specific scenarios, share data across teams, or spin up parallel test environments on demand. Let's explore synthetic data generation, a key part of K2view TDM. We start with a rule-based generation. Here we define domain-specific rules for selected fields, such as hotel location and features, and K2view generates fully compliant data across entities. In this example, we generate synthetic hotel data using a combination of rule-based logic and GenAI. Structured fields like hotel category, room types, and capacity are created using traditional rule-based generation, ensuring validity and business realism. Meanwhile, GenAI is used to generate rich contextual content, hotel names and descriptions, locations, and user reviews. The generated hotel description and location are aligned with the country, state, and city values generated through rules. Similarly, the hotel reviews are tailored to reflect the tone and attributes of each AI-generated hotel description, creating a consistent and believable test dataset that feels production-like without exposing real customer information. By combining these approaches, we get the best of both worlds: control, and creativity. K2view's GenAI functionality is built around two key phases: training and generation. Let's start with training. We begin by extracting, subsetting, and masking production data, ensuring privacy while retaining structure and realism. A major advantage of K2view's approach is the ability to subset the data based on what we plan to generate. For instance, if we're generating hotels located in the US, there's no need to include non-US data in the training set. This results in a much more focused and relevant model. This intelligent subsetting significantly improves training quality while reducing compute time and resource usage, producing a more efficient and purpose-built AI model. Once training is complete, we move to the generation phase. Because the model was trained on context-specific data, hotels from the US in this case, it produces high-quality synthetic output that aligns closely with the rules and structure of the target dataset. We can now generate AI-driven content, such as names, descriptions, locations, and user interactions that is not only coherent but also contextually and structurally aligned with the underlying data. The result is rich, production-like datasets that are fully synthetic and privacy-safe, ideal for use in testing, training, or development environments. In this demo, you saw how K2view integrates effortlessly with Couchbase, providing secure, scalable, and intelligent test data solutions, whether you need real data, mass subsets, or entirely synthetic records. Thank you for watching.